What's up, sports fans? Here's the study guide for Unit 4 quiz, Unit 4 test. It's all about exponential growth and decay. You can see the rubric here on the top. To get a 4, correctly identify solutions to exponential growth and decay problems in context. So that's like these two examples at the bottom that we'll get to. First, label the parts of the exponential function as shown. So I need you to tell me what the a represents, what the b represents, and then I don't need you to show me what the x represents, but it's nice to talk about. The a is our initial value or our starting point. So all of these have some initial value, initial number of people in a population, initial cost of an item, etc. So there's some starting point. That's your a value. Your b is your constant ratio, or another way to describe that is a multiplier. So it tells us what we're going to multiply by, and the x tells us how many times we're going to multiply by b. So we start with this, we start with some a value, multiply it by b. Then the question becomes, how many times do we multiply it by b? Well, x number of times. Okay, over here, we're going to write an exponential growth or decay model, which is the equation for each of these two situations. So we're starting off kind of simple before we level up. The initial value here is 2,180 or 2180. So that's my a value. My growth rate is 2%. Now this needs a little explaining. That means our b value is going to be 1.02. So what we need to remember here is how to convert percentages into decimals. So 2% equals 0.02 because what 2% is saying is it's 2 parts out of 100. If you take 2 and divide it by 100, you'll get 0.02, which is this business here. Well, why is this 1.02 instead of 0.02? Because if we're growing at a rate of 2%, then we need to multiply by a number that's bigger than b. So we take the number 1 and we add our growth rate, which is 0.02. Add those together, 1.02. That's where this comes from. So your kind of your homeostasis, your norm, if you multiply by 1, nothing changes. So that's your baseline. If you're growing, your multiplier is going to be some number bigger than 1, in this case 1.02. If you're decaying, then your growth rate is going to be smaller than 1. We'll talk about that in a second. Okay, so this one, a value 2180, b value 1.02, and that's being raised to the x power because we're multiplying the red by the blue x number of times. This scenario doesn't give us that number of times, so this is as far as we can take it. Next scenario, decay. Initial value of 4,025, that's right here. Decay rate is 13%. Decay means go down or get smaller. So in this case, again, we started our baseline of 1. This time we subtract 13%. That's 0.13, and we get 0.87. As a reminder, with percentages and decimals, 13% simply means 13 parts out of 100. If you throw that in your calculator or just move the decimal point over, you'll see that 0.13. This 0.13 is where I got this. I subtracted it from 1 to give us 0.87, which is our constant ratio or our multiplier. So we start with 4,025, multiply it by 0.87. How many times? I don't know, X number of times for this particular example. Okay, moving up. Complete the steps for finding the value of a sports car after 67 years of depreciation. Depreciation means it's going down in value. Appreciation would mean it's going up in value. So our initial value, our A, is 150,000. Our B value we get from our decay factor. The decay factor means it's going down 13% per year. Coincidence that these are the same, but they are nonetheless. So our B value is going to be 0.87. And this time we do have an X value. It's 6D7. Write the function to model the exponential decay. So that's y equals a times b to the x. That's the same thing we have above. Now we're going to plug in the pieces. We know that a is 150,000. So this a turned into 150,000. B, I'm kind of showing the long way here. I'm explaining my process. 1 is our baseline, and I'm taking away 0.13 because of that 13% loss per year. And I'm raising it to the 67th power because we're talking about 67 years. This part here, simplify. 1 minus 0.13, that's 0.87, already been discussed. Everything else is as it was. I then threw this into my calculator, and I got a silly result. I got $13.30. Now, the reality is this sports car, even if it's depreciating at 13% per year, it's not going to keep depreciating at 13% per year. Eventually, it's going to become vintage and desirable among collectors and whatever the case may be. You're not going to be able to go buy an old car for $13.30. That's just not real life. So admittedly, silly example, because we wanted to use 67 because we're hilarious. This car is going to be worth more than that, but this procedure is still good practice. All right, last one. We have this friend, hey you, they started a savings account with $7,777 for his baby when they were born. If that account earns just 1% interest each year, how much will it be in the account when the child turns 21? How funny, we changed genders, it looks like. Sorry about that mistake, but whatever. So it adds 1%. That's not very much. If you have a savings account that yields 1%, like 1% is free money, but there's more advantageous situations for you there. So the initial value, $7,777. That's our A. The B value comes from this interest rate. We know interest rate means we're gaining money, we're adding money. So we're taking our baseline of 1 and we're adding 1%. We're adding 0.01, and that's where we get this B value of 1.01. That's our B. Our X value here is 21 because we're talking about 21 years down the road. That's how many times we're multiplying by our multiplier. So A goes where the A goes, B goes where the B goes, X goes where the X goes. Then you can throw it into your calculator. This times this raised to that power. I got $9,584.31. And what that means is with an initial investment of this much, after 21 years, they ended up with this much after doing nothing. So again, free money is cool. It's almost $2,000. But if in real life, you're going to find something with a higher than 1% interest rate. Otherwise, it might not be worth your time. There's better ways to invest your money than this. These are the type of skills we're looking for on your upcoming test. Be able to identify your A, identify your B, identify your X, and then throw it in the calculator, explain what's going on in context. For example, if you just wrote 13.3, that is not a good, reasonable response because we are talking about a car, the value of a car after time. I need you to tell me the car is worth $13.30. Again, silly example, but that's what the result says in context. This one here, we need you to say that the amount in the account is $9,584.31. It's not just a random 9,500 result. You need to explain it in context, and that is explained here in our rubric as well. Okay, this is your study guide for upcoming quiz and test. You got this.